All right, greetings everyone. Welcome now to the third part of the video for section 5.4. And now, like as I previewed in the last video, we're going to get into what many students will tell you is their favorite part of trig. And when I say their favorite part, what I actually mean is the part that they actually absolutely disdain and hope they never see again. Okay, so let's jump right into it. So we're going to talk about simplifying expressions, trig expressions, using those identities that we've learned, okay? And so that's, when I say those identities, I'm talking about the ones where tangent is sine over cosine, cosecant is 1 over sine, secant is 1 over cosine, and cotangent is cosine over sine, okay? So let's look at the first problem here. And you'll see there on the left, it's sine over tangent, sine theta over tangent of theta. And first of all, you might think, oh, that looks totally fine. I don't see any problems with that, Cody. Which there isn't really, but there's actually a simpler way to write it. And so that's what we're going to try to accomplish here. Now, when we're going to do this type of problem, unfortunately, there is no technique I can tell you do it this way every single time. But one thing, or one hint I can give is to start by writing everything in terms of sine and cosine if you can. So for example, there on the top, that sine of theta, we'll just leave as sine of theta. But the tangent there, as I just mentioned a minute ago, that can be written in terms of sine and cosine, right? So we can write that as sine of theta over cosine of theta. And looking at that, you may be thinking, well, dude, I think you just made it more complicated than it was before, which is maybe true, but it's going to help us in simplifying. Okay, now notice even though there's a bunch of letters flying around there, what we're really looking at here is something divided by something. And notice that that second part is a fraction, which means we'll now want to invoke our division with fraction rules, which means we need to write that top part, that sine of theta, as a fraction, which we can do is writing that as sine of theta over 1. So what we're looking at now is sine of theta over 1 divided by sine of theta over cosine of theta. We'll again use our division with fraction rules to write this as sine of theta over 1. Change division to multiplication. Flip that second fraction, so make that cosine of theta over sine of theta. And now we're multiplying with fractions, and notice that in this fractions, there's a sign up here and a sign down here, so we can cancel those. And we multiply straight across them, we'll get a cosine of theta on the top, and then a 1 on the bottom, and cosine of theta there then just becomes, or cosine of theta over 1 just becomes cosine of theta. And that's our answer. Okay. Great, wasn't that fun? I think it's fun. All right, now something I want to point out about this. In the answer, notice that I wrote cosine of theta. I didn't just write cos, okay? I wrote cosine of theta. That's really important. I'll often see that students, as they're doing this, as they're working through, say, these steps or these steps here, they'll drop the angle and then just write cosine as their final answer, or just cos, actually. That's not correct. You have to have what's called the argument there, the angle that goes inside, and that's how we remind ourselves that this is a function and not just a set of words. All right, let's look at the second one now. So the secant of theta times 1 minus sine squared of theta. And we'll again want to use our trick of rewriting this in terms of sines and cosines. So we first of all know that secant of theta, that's the same as 1 over cosine. And then we have that 1 minus sine squared theta. in the parentheses there. And at first you might think, well, there's not much we can do with that because it's already in terms of sines and cosines, right? We see a sine there. So we would just have that 1 over cosine times 1 minus sine squared. It doesn't look super friendly to me. So what are we going to do instead? Well, let's think back to a nifty identity we learned in the last section, the one that was called the Pythagorean identity, which you hopefully remember was sine squared of theta plus cosine squared of theta equals 1. And when we look at that and compare it to this expression here, the 1 minus sine squared, do we see how we could maybe get 1 minus sine squared here in this equation? Well, what if we did this? What if I subtracted sine squared of theta from both sides of the equal sign? So subtract it here, and also subtract it over here. Well, notice when I do that, on the left, the sine squared theta minus sine squared theta, that cancels out. And so we're left with just cosine squared of theta here on the left, equal to, there on the right, we have 1 minus sine squared theta, which we cannot subtract those two since they're not like terms, right? The 1 does not have a sign with it. So we just write that as 1 minus sine squared of theta. And notice when we do that now, what we have here on the right-hand side is what I circled up here. And we have that is equal to cosine squared of theta, which tells us we can take this cosine squared of theta here and substitute it in for 1 minus sine squared theta. And I should emphasize it's taking the place of that whole thing there, the 1 minus sine squared theta. So what our expression now becomes is 1 over cosine of theta, so that part's not changing, times now, instead of 1 minus sine squared, we're putting the cosine squared of theta in its place. So our problem has now become 1 over cosine times cosine squared over of theta. And that works nicely because now we have a fraction times something. We can make that something a fraction by putting it over 1. Again, notice a cosine can cancel here. Cosine squared means cosine times cosine, so we can cancel 1 out there. And if we multiply straight across, we'll end up with cosine of theta on the top over 1 on the bottom, which will just become cosine of theta again. So we actually get the same answer that we got on the last one. Okay. All right, aren't these fun? Yeah, I know, you're glad you took trig for this. Okay, let's look at another example related to this. And this is now where we're going to prove an identity. And when we prove an identity, basically what happens is we're given an equation. So we're given that this thing here equals this thing. And we need to prove that that's true, that the left-hand side equals the right-hand side. Okay? And this is one of those examples of where they've actually given us the answer. And what's important here is not finding the correct answer, it's the process we take to get there. Okay, and in this case, with problems like this, again, there's no way I can tell you how to do it every time. But one common strategy is to start with the left-hand side, change some things, manipulate it a little bit, and try to make it equal to the right-hand side. And to begin that process, we'll do the same thing that we did before, which is we're going to rewrite everything there on the left in terms of sines and cosines. So the tangent here we'll rewrite as sine of theta over cosine of theta, since that's what that is equal to, plus cotangent. Recall that one of the identities for that is cosine of theta over sine of theta. So we've changed this tan of theta plus cosine of, or cotangent of theta into sine of theta over cosine of theta plus cosine of theta over sine theta. You notice what we have now are two fractions being added. When we have two fractions being added, what do we need in order to add the two fractions? That's right, we need a common denominator. So between cosine of theta and sine of theta, again, I know these are functions and all that, but we can still treat them just like we do any other fraction or any other number. So notice there's nothing common between the two of those. So the way we can get a common denominator here is to actually multiply them. So we can make the common denominator cosine of theta times sine of theta for both of them. And then because we're changing the denominators, we also have to change the numerators. So we have to think about what we multiplied each denominator by to get the new common denominator. So to go from cosine of theta to cosine times sine, we'll notice the difference there is we've multiplied by sine. So we'd also have to multiply the top there by sine. So if we take that sine theta and multiply by another sine theta, that's sine theta times sine theta, which will give us sine squared theta. For the second fraction, our denominator was originally sine of theta, and it became cosine of theta times sine theta. So what changed is that we multiplied by cosine. So we'll do the same here on the top, multiply cosine of theta there by cosine of theta. So we'll have cosine of theta times cosine of theta, which will give us cosine squared of theta. Okay? And again, this may be another instance where this is looking way worse than it was when we started, but I promise this is helpful. So now we have two fractions with the common denominator. And remember, when we add fractions, we keep the denominator. So we'll keep this as cosine of theta sine theta. And then we add the numerators. So we'll do a sine squared theta plus the cosine squared theta. Again, those are not like terms, so we're just going to leave that as sine squared theta plus cosine squared theta. But notice what that's given us on the top now. This sine squared theta plus cosine squared theta hopefully looks familiar from the problem we just did. That's our Pythagorean identity. And you'll hopefully recall that that is equal to just 1. So what this expression now becomes is 1 over cosine of theta, sine of theta, and then you might see the final step already. But if not, I'm going to rewrite this as 1 over cosine of theta times 1 over sine of theta. Hopefully you see that these two things are the same, right? Because if we multiply straight across on the bottom one, we have 1 times 1, which would give us the 1 here. Cosine of theta times sine of theta would give us this, so those two are the same. And that's helpful now because notice that 1 over cosine, that first thing there, well, we know that that's equal to secant of theta. And 1 over sine gives us cosecant of theta. So we see that we get what we're supposed to. All right. Whew. Wasn't that fun? Yeah. Okay, this might be a problem that it might be helpful to go back in the video and rewatch and pause along the way to make sure you have every step down. But if you have any questions about it, feel free to reach out to me. Okay, thank you so much for watching.